Hello everyone. Today I am going to explain about one of the confusing as well as interesting question in the power system. It is question regarding the star data connection of the power system. Here is a question. Three identical single phase impedance load are delta connected to make complex three phase load. Okay. Assuming balance condition, select the answer below that describe what would happen if same load are connected star instead of delta. Okay, I want to repeat the question once again. Three identical complex single phase impedance load are connected to make complex three phase load. Okay, and assuming loads are in balance condition. Select the answer below that describes what would happen if the same load are connected star instead of delta. Option A, the load would draw the same amount of current. Option B, the load would draw 1.3 times more line current, that means root 3 times of line current. The load will draw 1.3 times less line current. And last one is load would draw 3 times less line current. Okay. To explain this question, I wanna describe it by drawing the network diagram. Let's see. First of all, a single phase load is connected in delta connection in order to make three phase load. Okay, let us assume this is R and this is Y and this is B. Okay, and let us assume that this point is A, this point is B, and this point is C. Okay, and let us also draw at the same time star connector system. In star connector system, we will draw like this: Y connected or star connected system. Okay, R, Y, B. Okay, now here let us assume that we are supplying 400 volt. Okay, 400 volt. Then let us calculate the line current. Okay, for the simplicity, I am supposing the load are 1 kilo ohm each phase. It is saying complex power. Complex power is mixture of real and reactive power. But here, for the simplicity, I'm assuming loads are purely resistive. Let's calculate the current in AB leg. Let assume the current in AB leg is IR and BC leg is IB and IY, sorry, and CA leg is IB. Okay, direction is like this. Now IR equal to, you know that in delta connection, phase voltage and line voltage are same. Okay, so IR equal to 400 upon 1000. Okay, so this is phase. If we want to calculate the line, then root 3 times of 400 upon, if you calculate this value, you will get 0.69. Okay, now here we are connecting same load using star connection. Okay, 1 kilo ohm, 1 kilo ohm, 1 kilo ohm. And in star connection, there will be neutral. Okay, 400 divided by root 3. That means this one is phase voltage R2 neutral. Okay, here you should remember one thing. In star connection, phase voltage is 1 upon root 3 times of line voltage. Okay, so here let us calculate the line current, and you should know line current and phase current in star connection is always same, whereas phase voltage and line voltage are always same in delta connection. But line current is root 3 times of phase current in case of delta connection. Similarly, line voltage is root 3 times of phase voltage in star connection. So let's calculate line current as well as field current is equal. Here we can get root 400 divided by root 3 divided by 1000. Okay, if you divide this value, then you will get 0.23. If you compare these two values, what you can see is the current draw in star connection is 1 upon 3 times. That means 3 times less as compared to the delta connection. If you heard about the star delta connection in the motor starting, we use star delta connection in motor starting because if we start motor using star connection, then it draw 1 upon 3 times less line current as compared to the delta connection. So if your motor is three phase delta connected, then while starting we use star connection in order to reduce line current. This is the one of the example how we reduce the current during the starting of motor. Okay, that's all for today. I will come with new video. Thank you for watching.